of the derivative. In other words, you just differentiate twice. So a third derivative would be differentiating the function thrice, and so on. So in other words, in symbols, if this represents the second derivative denoted by two apostrophes there, actually, f prime prime, it's just the derivative, this is the differential operator of this one, which is the first derivative. And that's it. Let's just illustrate. So we are to note the second derivative. But of course, to get the second, we need the first derivative. So we differentiate f of x first. So to that, we need the product rule. Again, first times derivative of the second plus the second times derivative of the first. Simplify. Okay? Rearrange lang ito, 2x ln x, x squared divided by x. And then, again, differentiate. So term by term, derivative of the first is 1. Then we differentiate the second term. This is a product. So we'll think of it as 2x times ln x. So it's 2x times derivative of ln x, which is 1 over x, plus ln x times derivative of 2x, which is 2. Product rule lang yan. And then simplify. 2x divided by x, provided x is not 0, of course, is 2, which adds to 1. So we have 3. And then rearrange 2 ln x. Another one. Now, medyo mahaba ito dahil mas complicated konti yung second derivative niya. First derivative niya. Kasi quotient na siya. So let's apply the quotient rule first. Derivative, denominator, derivative of numerator. Okay, compare nyo na lang doon. Minus numerator times derivative of the denominator. And then square of the denominator. Now, let's simplify the numerator by mere rearrangement lang. Ginanon ko na lang siya. Now, to get the second derivative, we need to differentiate this. And again, we need the quotient rule. But it's more tedious since you have to differentiate several products here. Okay, let's go. Bago yon, kailangan muna nating mag-cancel para mas madali. I factored out x squared. And if you do so, it will cancel out with the x to the 6. So you'll be left with this. Okay? Questions on that, just send to the chat box. Now we can proceed. Differentiating. This is the denominator now. And then this is the derivative of the numerator. So to get the derivative of the numerator, we differentiate the first term. So kailangan natin yung product rule dito. First times derivative of the second plus the second times derivative of the first. Okay? Then, derivative nito, constant function rule. Derivative of e to the x is itself times 3. And then, we're not done yet. Don't forget. Okay? Minus. Okay, nasa na tayo? Minus. Okay, I'm wrong here. This should be minus. The numerator times the derivative of the denominator. So this is the numerator times the derivative of the denominator. So 4x cubed. And then all over the square of the denominator. Now actually, when we give problems like this, we do not require you to simplify further. All we need to see is the process, the correct application of the formulas. So we will be checking each term here, give corresponding credit or points, and then that's it. However, I won't show you the simplification since I made an error. This should have been a minus. So I did the plus. Okay? So, mali na lahat na nandito. But anyway, just change this to a plus, this plus to a minus, and then that's it. It's not required to simplify. Now we need to move ahead of what we ought to finish today. Since if you've already seen the quiz or the graded exercise, you may have not answered it yet, since most of the questions there involve trigonometric functions, and I plan to reach up to that last topic. But very simple exercises, I'll reserve the practice or more difficult examples for Thursday. So, ang ginagawa ko lang, give the formula, simple illustrations or examples. So now let's have the chain rule. Instead of giving you the chain rule per se, I have just given you the particular chain rule for the several types of functions we usually encounter in algebra or calculus. So like the power, the logarithm, the exponential, and then later trigonometric functions. Now here's the chain rule or the general power rule actually, or let's just call it chain rule for power functions. So notice here that instead of this being x, this is now y, which is a function of x. So notice the differential operator and the function are different variables this time. And it's almost like the simple or the basic power rule. You bring down the exponent, subtract 1. But in addition, you multiply it by a factor, which is the derivative of the base. So you differentiate whatever this base is, this function is, with respect to the variable. Now, it will be very easy once you see an illustration, the one here. So how about this? Can we just directly apply the basic power rule and just bring down, then subtract? No. We have to multiply by the derivative of the base. The base here is not x, but 3x minus 4, a function of x. So according to the chain rule, you bring down the exponent. That's 3 there. You subtract 1, and then you differentiate this one here, the base. Okay? And the derivative of the base is 3. And then you simplify. So you have 9 times quantity 3x minus 4 squared. Now, we could get the derivative of this actually by expanding first, then differentiating term by term. But that's not efficient. You can quickly get it using the power rule. However, definitely, we don't do expansion first when we have large exponents. So instead, we resort to the general power rule or the chain rule for power functions. So again, we bring down the exponent, subtract 1, and differentiate the base. 7 has derivative 0. So derivative of x cubed, 3x squared. Simplify. Chain rule for exponential functions. So almost the same. Remember, the derivative of e to the x is e to the x, but this time it's e to the y with respect to x. So it's still e to the y, but with the factor y prime, which is the derivative of the exponent here. Let's illustrate. So how do you get the derivative of e to the x squared? Take note, this is no longer e to the x, but a function of x squared in this example. So it's still the same, you copy, but differentiate the exponent. So differentiate x squared, which is 2x. So that's the answer, 2x e to the x squared. Another one, e raised to that function, 1 over x to the 4. Apply the chain rule. Rewrite first as x to the negative 4, yung 1 over x to the 4. And then apply the chain rule. Copy. And then differentiate the exponent. Differentiating x to the negative 4, power rule. Bring down, subtract 4. And then simplify a little bit. You could write it, of course, as over x to the 5, but negative exponents are allowed as answers in calculus. So just leave it as x to the negative 5. Can even leave 1 over x to the 4 as x to the negative. Okay, as I have said, just basic examples, give you the formula, illustrate basic, simple examples, and then by Thursday, the harder ones. So here's the chain rule for logarithms. So it's the same. Differentiate ln y, it's the reciprocal of y. Remember, derivative of ln x is reciprocal of x. But again, with the factor y prime. Multiply by y prime. So we just write it along the numerator. Y prime over y. The straight. Derivative of ln, quantity x cubed plus 2x. So you differentiate first the expression inside the ln, denoted by this symbol, all over that expression. Okay? Differentiating that expression, you get 3x squared plus 2, and then all over x cubed plus 2x. And no further simplification can be done. So that's the final answer. Again. Okay. Differentiate the term inside. Ito yan. The derivative of x to the 8 is 8x to the 7. And then derivative of e to the x cubed is itself times the derivative of the exponent. Chain rule yan for exponential functions. So 3x squared. Then copy the expression. Simplify. Ni-rearrange lang konti. Okay? So kung ganito lang, medyo madali lang talaga yung mga rules. Basta't memorize mo at alam mong gamitin. And finally, trigonometric functions. I believe you haven't discussed this in Math 21 due to the lack of time. Kasi yun yung napag-usapan namin ng mga teachers. But anyway, you don't need a thorough understanding of trigonometric functions. There's a calculator anyway if you need to calculate values. But here, the thing you need to know, the only thing you need to know is the derivative of the trigonometric function. So for example, here in this set of formulas, we see that the derivative of the sine function is just the cosine function. And the derivative of the cosine function is just the sine function negative. So just take note of those two and don't, what they call this, mistake the negative sign for the other formula. The one that has a negative is the derivative of the cosine. Now, here are the chain rules for those derivatives. So if you replace x by a function of x, y, you just multiply by the derivative again. So it's the same. Derivative of sine y is cosine y times derivative of y. Derivative of cosine y is negative sine y times derivative of y. So it's always just with the addition of the derivative. So laging may y prime lang sa mga chain rule, di ba? So illustrate na lang natin. So how do you get the derivative of sine x to the 5? So it's just, you know, the derivative of the sine is the cosine. So just copy cosine, get the cosine of the expression inside. Ito yan, cosine x to the 5. And then differentiate the expression inside. So differentiating x to the 5, we get 5x to the 4 cosine x to the 5. Cosine ln x. So derivative of cosine, this is the outer function. So you have to use the formula for trigonometric functions first before logarithmic functions. So derivative of cosine is negative sine. So ito yon, negative and then sine of the function inside, which is ln x. And then differentiate the function inside cosine, indicated by this one. So 1 over x. And that's it. So no more. I will just be meeting you again on Thursday for just 30 minutes to do some exercises that are a little more complicated than the ones we have discussed today. Is there any question? So if there's none, that's it for today. Okay, bye.